On your screen is the F-35 Lightning II. One of the most recognized combat aircraft of the modern era, designed and built in the United States. It is the standard an entire alliance has aligned around. From Europe to the Indo-Pacific, thousands of pilots, hundreds of bases, and a networked, multi-domain way of war are being built around a single platform. But there is an uncomfortable truth the Pentagon understands better than anyone. In modern warfare, you do not lose the advantage only because the other side gets stronger. You lose it because you stay the same for too long. And that is why the United States is spending more than $16.5 billion on a single upgrade package called Block 4. This is not about buying a new fighter. It is not about replacing the fleet. It is about re-architecting the platform that has been treated as the fifth-generation gold standard. $16.5 billion is the kind of money many countries would call an annual defense budget. But in Washington, this is not spending to be a little better. This is spending to keep the authority to define the fight. In this episode, we are going straight at three questions that matter. What is the United States seeing that makes it willing to overhaul the F-35 at this scale? What exactly does Block 4 change, layer by layer? And which layer is the one that actually keeps adversary planners awake at night? And finally, does this transformation keep the F-35 as the benchmark of air power for the next decade? Or is it simply a sprint to avoid being caught? This is the story of a platform that dominated and still has to evolve to survive. Part 1. The gold standard and the new threat. There is a reason the F-35 is not like any fighter that came before it. The F-15 won because it dominated in air-to-air combat. The F-16 won because it was agile and affordable enough to field at scale. The F-22 won because for a long time it was essentially an unmatched stealth hunter. But the trade-off was limited numbers. Adversaries did not just build better aircraft, they built a network designed to turn the battle space into a no-go zone. The term is A2AD, anti-access and area denial. A2AD is not a single system, it is a linked chain. Long-range ground-based radar, long-range surface-to-air missiles, electronic warfare systems that jam communications and disrupt sensors, air and maritime sensors that fill in the intelligence picture, and more importantly, a new logic of war. You do not have to visually track the jet to beat it. You only have to detect early enough to cue, lock, and shoot while it is still on the way in. In that environment, stealth is an advantage. But stealth is not a magic shield. The United States has to start with something most viewers never see. Not missiles, not radar, but the heart of this entire transformation. In the next section, we go straight into the factor that slowed the Block 4 program down, the reason many F-35s have been forced to wait, and the element that will answer one simple question. Will the F-35 remain a very good stealth fighter, or will it become a true data warfare platform? Part 2. The TR-3. Heart surgery. If you want to understand Block 4, forget missiles and radar for the first few minutes. Because Block 4 does not start with firepower. It starts with a blunt reality. The F-35 hit its ceiling. Not in speed or aerodynamics. It hit the ceiling in the one area that decides who wins in modern air combat: data processing capacity. The F-35 is a fighter, but it is also a flying computing node. Every second in the air, it pulls in a massive volume of information from multiple sources: radar, infrared sensors, full-sphere situational awareness, threat warning, and data links to the rest of the force. Then it has to fuse all of that into a single coherent picture so the pilot can make decisions in seconds. Here is the problem. As warfare shifts toward data, the data load grows exponentially. And the hardware in earlier F-35 lots was designed for a time when algorithmic demand, electronic attack intensity, and upgrade tempo were not as punishing as they are now. You can have an outstanding stealth airframe, but if the brain cannot keep up, you start losing in quiet ways. You classify targets one beat slower. You filter out jamming one level worse. You build the tactical picture a few seconds late. And in beyond visual range combat, those seconds are not an inconvenience. They are the line between survival and a kill chain collapsing on you. That is why Technology Refresh 3 exists, TR3. Calling it an upgrade makes it sound harmless. In reality, TR3 is closer to open heart surgery because it reaches into the aircraft's core, the central processor, memory, displays, and the digital foundation required to run the next generation of software. Here is the simplest way to picture it. You cannot turn an old phone into a new phone just by installing more apps. You can install them, but it stutters, it overheats, it crashes, and eventually it cannot run the workload anymore. If you want to run heavy applications, you have to upgrade the hardware. The F-35 is the same. Block 4 is a new generation of warfighting applications, but to run it, the F-35 needs a new generation of hardware. TR3 is that foundation. It delivers a major jump in processing power and significantly more memory so the aircraft can do what the future battlespace demands: see, understand, and react faster inside a heavily jammed environment. Lockheed Martin effectively turned its parking ramps into one of the most expensive aircraft storage lots on the planet. Hundreds of F-35s sat on the ground, not because they could not fly, but because their new electronic heart was so capable that the software stack was not ready to fully catch up. In the past, when a fighter had problems, you thought about wings, engines, materials. Today, what slows you down can be software integration, processing margins, and digital stability. The more you push forward, the more complexity you accept. The more complexity you accept, the more you pay in time. And time is exactly what an adversary hopes you lose. So why does the United States still take this risk, knowing the cost? Because without a new heart, you cannot transform the aircraft. Without TR3, Block 4 cannot become what it is supposed to be. You cannot raise sensors to a new tier if the jet cannot process the new data streams. You cannot push electronic warfare into a more proactive posture if the system cannot compute in real time. You cannot expand the weapons portfolio because Russia and China are not trying to make the sky dark. They are turning it into a signal storm. Russia leans on integrated air defense networks like the S-400 and S-500, backed by electronic warfare that disrupts radar and data links, making it harder to lock targets and harder to coordinate as a formation. Electronic warfare means jamming and deception designed to degrade sensors and communications. China pushes A2AD as a networked system, combining long-range radars, reconnaissance satellites, and electronic attack to track from distance, then flooding the battlespace with decoys and interference so you see too many tracks, classify wrong, and react late. That is sensor warfare in its purest form. The F-35 has always relied on an AESA radar, an active electronically scanned array. Unlike older mechanically scanned radars, AESA uses thousands of transmit-receive elements to steer the beam electronically. That makes it faster, more flexible, and harder to predict. But Block 4 is aimed at a deeper step forward. Not just a better radar, but a different radar philosophy, built around 3 priorities: cleaner detection, stronger resistance to jamming, and better target classification. Here is the technical point you need, explained in plain terms. Gallium nitride, or GaN, is a next-generation semiconductor material used in radar transmit-receive modules. It allows higher power, better efficiency, and improved heat tolerance. In practical terms, with the same space in the nose, you get a stronger, cleaner headlight that is harder to blind. And in modern air combat, power is not just about seeing farther, it is about seeing correctly. Because the other side is always trying to jam you. They pump an electronic fog into the air so you misread, mislock, or waste shots. A radar does not win by being loud, it wins by being smart. It has to reject interference, hold stable tracks, and separate real targets from decoys and noise. That is why the radar upgrade in Block 4 should not be understood as simply more range. It is an upgrade designed to win inside an environment where someone is actively trying to ruin your eyesight. But radar is only one piece. What made the F-35 different from the start, and more different in Block 4, is how it turns multiple eyes into a single, fused picture. 2 systems matter here: EOTS and DAS. EOTS is the electro-optical targeting system. Think of it as a precision targeting eye, combining infrared and optical viewing to identify, track, and support weapons employment on a target. DAS is the distributed aperture system, small sensors distributed around the airframe that provide 360-degree coverage. It tracks heat signatures, detects missile launches, and delivers continuous situational awareness, including threats behind you that you cannot physically see by turning your head. When EOTS and DAS get upgraded in resolution and processing speed, the point is not prettier imagery. The point is the battlespace picture arrives faster and clearer. In real terms, that means the jet detects a missile launch earlier, recognizes the threat axis sooner, and warns sooner. It means better tracking of moving targets in worse weather from farther out. It means you do not have to run radar constantly because you have other eyes, reducing emissions and improving survivability. Emissions means the electronic signals that can give away your position. But even that is still just seeing. The winner is the one who turns sight into effects the fastest, while staying alive long enough to keep fighting. In the next section, we will talk about Sidekick, about increasing stealth bay firepower, and the weapons Block 4 was built to carry. Part 4. Sharper Claws. There is a very practical question anyone who understands air combat will ask the moment they hear the F-35 described as a stealth hunter. If it shoots first, how many times can it shoot before it runs dry? This is where earlier F-35 configurations have always been scrutinized. Not because the jet is weak, but because its design philosophy placed stealth above everything else. And stealth comes with a trade-off: internal weapons bay volume. In its standard stealth configuration, the F-35 carries 4 air-to-air missiles internally. In a classic view of air combat, 4 shots can be enough in many scenarios. But in today's sky, where adversaries can launch from farther out, where you may face multiple tracks, multiple decoys, and layered threats at the same time, 4 starts to feel like a psychological limit. You do not want to be the hunter who enters the forest already thinking about conserving rounds. That is why Sidekick becomes a small detail with outsized importance in the Block 4 story. Sidekick, in plain terms, is a redesigned internal rack system that uses the weapons bay space more efficiently. The result is that the F-35 can carry 6 air-to-air missiles internally instead of 4, while staying in a low observable configuration. Low observable means stealth focused on reducing radar detection. Going from 4 to 6 sounds like just 2 more, but tactically, it is a 50% increase in shots available in the aircraft's most survivable configuration. And Block 4 is not only about carrying more, it also opens the door to weapons the earlier configuration could not fully exploit. To keep this clear, we can group Block 4 weapons into 3 mission sets, because each one answers a specific fear. On Block 4, the F-35 effectively unlocks 3 real claws, and the point is that each one targets a different problem set. First is the AIM-260JATM. Earlier F-35 operations leaned heavily on the AIM-120, especially the AIM-120D. The exact range of the AIM-260 is not public, but the intent is obvious. Exceed the AIM-120D class to regain first shot advantage in beyond visual range combat. Put simply, the AIM-120D is often discussed in the rough around 100 miles class, and the AIM-260 is being built to go meaningfully beyond that. And here is the critical piece. Without Block 4, a next-generation missile does not become a true combat capability, because the aircraft needs the software and fire control integration to properly talk to the weapon. Second is the AGM-88GAAR-GMER. This is an anti-radiation missile, meaning it hunts the thing trying to kill you. Air defense radars that have to light up to search, track, and guide interceptors. ER means extended range. It allows you to attack those radars from farther away instead of having to push into the most dangerous part of the threat ring. Before Block 4, the F-35 did not have full standardized integration to employ the AAR-GMER as a routine capability. Block 4 is the milestone that puts it where it belongs, opening the door from standoff range, silencing the air defense network before other forces move in. Third is the GBU-53B Stormbreaker. This weapon is built for the most frustrating targets, moving targets in rain, haze, smoke, and degraded conditions. It uses a tri-mode seeker, meaning it can track in multiple ways, so it is not defeated by weather or a single deception method. It also has a two-way data link, which means it can receive updates in flight and adjust to a shifting target set instead of being a one-and-done drop. In plain terms, this is the kind of weapon that turns "I can see it" into "I can hit it" in the real world. And when the mission does not require maximum stealth, the F-35 can shift into beast mode, carrying external stores to overwhelm with volume of fire. It is not just a stealth hunter, it is a platform that can change roles. But the most unsettling part is not only what the F-35 can shoot, it is what it can do with data for the entire formation. In the next section, we go into the quarterback role, where the F-35 Block 4 becomes the central node of the fight. Part 5. The quarterback and the AI wingman. Block 4 does not just make the F-35 shoot better, it makes the F-35 command better. This is the most important role shift in the entire upgrade. The F-35 stops being a fighter that hunts only for itself. It becomes the quarterback, a central node in the battle space that pulls in data, fuses it, and then hands the right target to the platform that can deliver effects the fastest. In plain terms, this is about compressing the kill chain. Detect, identify, target, engage. The side that runs that chain faster shoots first and survives longer. The kill chain is the end-to-end sequence from sensing to weapons effects. The enabling technology can be summarized in 2 words: interoperability and AI. Interoperability means the F-35 can exchange tactical data with allies and other forces through gateways, instead of each element holding information inside isolated islands. That matters because in real combat, data is often fragmented, delayed, or degraded. Block 4 pushes the F-35 into a more reliable convergence point, turning airborne sensing into weapon-quality targeting for the whole force. Weapon quality means data accurate and timely enough to support an actual engagement, not just awareness. The next door opens. CCA, Collaborative Combat Aircraft. That means combat drones designed to fly with manned fighters as a team. The concept is simple. An F-35 with a pilot becomes the conductor, while the drones do the heavy lifting, scouting ahead, jamming, acting as decoys, carrying weapons into blind angles, and absorbing risk. The F-35 stays at standoff distance, orchestrates the package, and chooses the moment to strike. In summary, Block 4 turns the F-35 into a flying data center capable of coordinating an entire formation. And that capability comes with a physical price you cannot escape. More processing means more electrical demand. More electrical demand means more heat. In the next section, we go into the cost of perfection. F-35 as the benchmark for another decade? Or does complexity become the force that slows it down? Part 6. The cost of perfection and the final verdict. By this point, Block 4 sounds like the perfect upgrade. See farther, hit harder, and sit in the middle of the fight like a conductor. But every evolution comes with a bill, and with Block 4, the bill is not just money, it is physics, power and thermal, electricity and heat. The F-35 was already an electronics-heavy machine inside a stealth shell. When Block 4 pushes everything higher, data loads go up, processing goes up, electronic warfare goes up. And the rule is blunt and unavoidable. The more powerful the electronics, the more electrical power they need, and the more heat they generate. The F-35 Block 4 is not short on raw electrical generation. The engine can produce on the order of roughly 160 kilowatts. The constraint is PTMS, the Power and Thermal Management System, the system responsible for managing power and removing heat. It was designed to handle roughly 15 kilowatts of heat, but in practice, it has had to carry around 30 to 32 kilowatts. And when Block 4 is running at full demand, the cooling requirement can jump into the range of roughly 62 to 80 kilowatts. In plain terms, the jet can be more capable, but if it cannot shed heat fast enough, it has to limit itself or protect itself. Margin means extra capacity beyond the minimum, so you can surge without breaking limits. DOT&E, the Director of Operational Test and Evaluation, has noted that in hot conditions, while stationary on the ramp with bays closed, temperatures can exceed limits in roughly 10 minutes. When you see an F-35 sitting with its weapons bay doors open, it is not showing off. It is avoiding thermal shutdown, an automatic protective shutdown triggered by overheating. But it ensures the F-35 does not enter the next decade with the brain of the previous one. It keeps the F-35 as a platform that can detect earlier, understand faster, coordinate wider, and turn data into effects at the speed the new battlespace demands. The F-35 Block 4 is not a new aircraft. It is a statement. The United States is not waiting to be caught, and the fight for the sky is no longer a contest of speed. It is a contest of data. This is Future War Tech. See you in the next episode.